Do you want to know how to prevent the king from moving into this danger and also to prevent it from moving into this danger? Watch this video to find out. Hello and welcome to part 28 of the series on how to create a chess game with Reactjs. In this episode, we are going to implement the logic for preventing the king from moving into danger. But before we are going to that, we are going to fix a bug. A viewer has pointed out that we cannot promote any pawns. That's true, because if we move the pawn to the other side of the board and we pick, for example, a rook, we see that the pawn is still a pawn and that we don't have a rook. Thank you for pointing that out. Now we are going to fix this. First of all, we are going to open up our referee. So right here, we are going to open up the referee file, and then let's take a look at the method that gets executed when we promote a pawn. So if you move down here, we see that we have the images for the pieces that we can promote the pawn into. So let's refresh the page once more. And if we move the pawn to here, we get 4 images, which are those 4. And then once we click on an image, we execute the promote pawn function. In this function, we check if the promotion pawn is defined. If it is not defined, we want to return. And then we want to update the board by updating the promotion pawn with a new piece. We are not replacing it, we are updating the piece. So first of all, we don't want to assign the board.pieces directly because board is a state variable. If we go up here, we see that the board is derived from the useState right here, and we have the variable named board, and then we have the function setBoard in order to update the board. So we should use the setBoard function. So if we choose a bishop right now, nothing will happen. But what if we want to set the pieces to an empty array? Let's remove this and say that board.pieces is equal to an empty array. Now let's try and get the pawn to the other side. We still see all the pieces. This is because the pieces are never updated. The UI only updates when we update our board. And the only way to update our board is by using the setBoard function. So if we use that function, we say setBoard, then we have also access to the previous board value, which is previous board. And then right here, it expects a return value. So we need to return a new board. So what if we move this inside of here? And then let's say return board. The red line is removed. And now if we move the pawn to the other side of the board and we click on the promotion pawn, still nothing happens. And that is because React doesn't notice that our board has been changed. Well, what do you mean React doesn't notice? Because right here we are calling the setBoard function and we are returning our board. So it should update the board with this board, right? That's correct. But since board is an object, the setBoard function expects a new object to be returned. However, the object that we are returning right here is exactly the same object as that the board already is. So in order for React to notice our change, we need to make a new reference or a new object from our current board. And we can do this by saying board.clone. Now, if we save this up and refresh the page, then it should remove all the pieces everywhere. And this is one way to do it. However, by doing this, we first remove pieces from our current board and then we clone it. We actually want to reverse this. So we are going to say const cloned board is equal to board.clone. So now we are not modifying our current board at all. We are cloning it into a new board, and then we want to modify that new board. So our original board will not be modified in any way. And then right here we want to return our clone board. If we move the pawn to the other side of the screen, we see that it is still working as expected. Now, this is one step in the right direction. I'm going to copy this, and then we are going to pull up our previous code, which we have removed, because we do need that to update the pieces. So the code was this right here, like so. Here we were setting the board.pieces equal to this. Now I'm going to paste the code that we have just created right here, and instead of assigning the pieces of the clone board to an empty array, we are going to copy over this. We are going to remove the board.pieces is equal, and then we are going to paste it right here. But we are going to change one more thing, and that is replace the board with the clone board. All right. Now, if we save this up and refresh the page and move a pawn to the other side of the board, we see that the pieces are still standing, but our pawn is still a pawn. The reason why the pawn isn't updated is because the program or our code cannot find the pawn. Let's say in this if statement, if we find our promotion piece, we log something. Say we log, we found our piece. If we now open up the console and refresh the page, we move our pawn all the way up, we see that we never get the console.log, we found our piece. And that is because there is no piece that has the same position as a promotion pawn. So let's also log the position of the promotion pawn. We see that the position of the promotion pawn is also not logged. That's my bad because, well, we are not entering this log. So let's put it inside of here, promotion pawn dot position. And now if we refresh the page once more, we should see a log for the promotion pawn. It says that the promotion pawn's object or position is at 2,6, 0, 1, 2, and then 0, 1, 2, 3, 4, 5, 6. That is not the position of the promotion pawn. That is the previous position of the promotion pawn, which means that the promotion pawn doesn't have the updated position. Okay, so why don't we just update it to the correct position? If we scroll up to our state right here, we see that we have a function setPromotionPawn, and this function is being called right here. So this is in the playMove function. First we check if the move is valid, then we check if it is an ampersand move, and then down here we want to update the board. We check if the pawn is in a promotion row, and then we also check if well, here we determine a promotion row, and here we check if the pawn is in a promotion row. If it is, then we want to set the promotion pawn equal to that pawn. However, the position of the plate piece has not been updated. As you can see right here, we are comparing the promotion row with the destination.y, not the plate piece.y. So in order for the plate piece to have the correct position, we need to set it equal to the destination. So instead of setting the promotion pawn to the plate piece, we want to set it to something else. First, we are going to access the previous promotion pawn, and then we create a function which returns a pawn. So right here, we could say return plate piece, and this is exactly what we had before. But instead of doing that, we are going to create a new const, which is cloned plate piece is equal to plate piece dot clone, and then we want to return this clone plate piece because we don't want to modify our current piece. We want to copy it, and then in our clone we want to modify the clone. So we say cloned plate piece dot position is equal to destination, and we can also say destination dot clone to be sure that the destination of this cloned plate piece will not be modified anywhere else. Alright, so now that we have this, we can refresh the page, and if we move the pawn up, let's take this one, and we make a bishop out of it, we see that we have a bishop. Great. Well, we can move it back down, and that is because the underlying type is still a pawn. The underlying type of this rook is a pawn. So if we move this rook to here, we see that it turns into a pawn, and we can promote it again. In order for us to see what's going on, we are going to console.log the plate piece right here, and then we want to open up the console and refresh the page. And now we see that the move that we played was with the pawn right here as well, with the pawn here as well, and then up here, if we turn it into a rook and we move this rook, say for example here, we see that the type is still a pawn. So how could this happen? Because we have just, if we scroll down, promoted the pawn to a rook. We set the piece type to the rook, team type to our, and then the image according to the type. And if we scroll up, we see that we get that piece right here. So how can the piece, which was a rook in the function below, how can a piece become a pawn right here? Well, that is because we have modified an existing piece. To break it down, we have two piece objects. We have the general piece, and this piece is just any piece except for a pawn, because for the pawn we have this class. So this class extends from the piece, and this has an extra property, ampersand, for the pawn, because only the pawn can ampersand. And it also has a special function for the clone, since the pawn also needs to pass the ampersand in the constructor, and we can immediately say that this pawn is of piece type pawn. Alright, but what does this clone have to do with the play piece right here? Well, if we go to the place where this playMove method gets called, the playMove method gets passed to the chessboard. If we open up the chessboard, we have at the top a property named playMove, which we get passed from the referee. And if we then go to the place where this playMove gets executed, which is right here, we see that the playMove gets called, and the parameter that's being passed in is a current piece.clone. So right here, we are cloning the current piece. Alright, so what if we console.log the current piece right here? Let's refresh the page, and we see that we have in our chessboard a pawn, and in the referee we have a pawn. Still always the pawn, chessboard a pawn, referee a pawn. However, right now, if we move this rook to here, we see that we have in the chessboard a rook, and in the referee a pawn. So that means that the current piece right here is a rook, and in the referee, the current piece, if we go up here back, the referee, here we have a pawn. So the conversion happens between here and here. But how does it happen? Well, it happens because we use the clone function. So the piece that we have is not of type piece, but it is of type pawn, which is right here. So we have modified the pawn so that the type of the pawn is a rook. The image is also of a rook, but the underlying object type, so the underlying class, is still a pawn. Which means that if we call the clone method, we will get a pawn as a return element. Which means that we get a new pawn, and in the pawn constructor it says, hey, the piece type is a pawn. That's why our rook is being transformed into a pawn. Now, I'm going to remove the console.log from the chessboard and the referee, and we are going to move down to our promotion pawn method, or the promote pawn method right here. And in this method or function, we are going to fix this problem. Instead of modifying the current piece, we want to create a new piece. So right here, we want to say results.push. And what do we want to push? We want to push a new piece. And this takes in some arguments. The first argument will be piece.position.clone. So we want to clone the position from the pawn that we are promoting. Next will be the piece type. Well, that will be the piece type that we get passed in from our promote pawn function right here. Then we will have a team, which will be the same as the team of the piece, which means from the pawn. And then we will have a possibleMoves array. Let's leave it empty for now. Alright, so here we create a new piece, and we can remove this because the type is being set in the constructor already. The team type is also being set in the constructor. And here we have the logic for determining what the image of the piece is. Well, that's not necessary anymore. I'm going to remove it right here. And the reason why it is not necessary anymore is because if we go into our piece constructor, we see that the first line of the constructor is determining the image based on the type and the team that it gets passed in. So if we say that the type is a rook, for example, and the theme is white, then we get automatically assets/images/rook_w for the theme type.png. We don't need to specify the image ourselves anymore. It gets calculated based on the properties that we add in a constructor. So right here, we push the piece, and then let's see. What we don't want to do anymore is always execute this. We want to wrap this in an else. We are going to add a bracket right here to open the if statement. And then once we have encountered the promotion pawn, we don't want to push the piece in the results anymore. So normally we do, but once we have the promotion pawn, we want to create a new piece to push in the results array. So it looks like this. We have our promotion pawn, then we push a new piece in the array. Otherwise, if it is not a promotion pawn, we want to push the existing piece into the array. All right, let's save this up, refresh the page. And if we now move with our pawn, let's close the console, to the opponent's side and make a horse out of it, or a knight, then we see that we can move with the knight. But as you can see, the first time that we moved with the knight, we didn't get any indicators of where to move to. Well, in order to fix that, we want to comment the update possible moves in again. And we also want to move it from here inside the setBoard method. So the update possible moves calculates the moves for a given board. Well, we don't want to call the update possible moves method or function. What we do want to do instead is we want to say clone board calculate all moves, I think. Yes, that was the correct one. So we want to say calculate all moves on the clone board after we have assigned the pieces. Now let's save it up, move the pawn to the other side, and then change it to a horse, and we can see that we can move, and we can take, and we can move. Great. The next problem has also been pointed out by the same viewer, who has pointed out that the promotion pawn wasn't working, and that is that if we move our pawn to the promotion row immediately, without taking additional steps, we also get to see the model, which we shouldn't, because, well, it's not legit to make that move, right? That is something that we are going to fix while working on preventing the king from moving into danger. All right, so preventing the king from moving into danger. First of all, let's get a scenario. So we create a scenario right here for our, that's the queen, for our king. Say if we have the king right here, we should not be able to move the king into the spot right here where I'm hovering the mouse, because this spot is being attacked by the pawn right here. The king should only be able to move to every other tile except for this green one here. But it still has a circle and we can also still move there. Now the king is in danger, and that's not something that we want. So when do we calculate those circles? Those circles are calculated based on the possible moves. So let's see where we calculate the possible moves. It's in this method right here. And then we go inside of the board. We say board.calculate all moves. And right here, we calculate all the moves of the pieces. So let's add a comment, calculate. So now we have a list of all the possible moves for all the pieces. However, we don't know if the moves that are possible are also legit or are also valid. So in this example right here, well, I needed to refresh the page, unfortunately. But in this example right here, we cannot move the king down. So this is a possible move, but it is not valid. So we want to remove this move from the possible moves from the king. In order to do that, we want to simulate all the moves for the king. And then we want to check for each position, can the king be attacked by any of the opponent pieces? We are going to say for const move of pieces dot find, and then we want to find the king. Let's say in this case the black king. So we want to find the piece type or is king, and then we want to also check p.team is equal to, do we have the current team which is playing? I don't think so. So let's say p.team is team type dot opponent. Now we should get a piece which is the opponent king, and then we want to get the moves from there, so possible moves. And it says that it does not like this because object is possibly undefined. Okay, well, fair enough. Let's create a constant right here. Const king is equal to, and then we are going to put this code inside of here. And then right here we can say king.possibleMoves. It still should be undefined, but we can easily eliminate that situation by saying if king is equal to undefined turn. And then we should be able to access the possible moves from the king, because, well, it's not true, because the possible moves can also be undefined. Let's say that the possible moves are always defined, or we can add a check right here. So right here we check if the king is undefined or the possible move is undefined, return. If not, we want to do this, and this is the juicy part. Okay, so now that we have all the moves for the king, let's first of all create a constant for the original position from the king. So const original king position is equal to king.position.copy or clone. And then at the end of all the simulation, we want to say king.position is equal to original king position. Then right here, we want to say simulate king moves. Cool. So right here, we can simulate the king moves. So we're going to say king.position is equal to move. Right now, the king will move to, well, it's crashed again because we have saved this. The king can move to the upper left, upper right, well, actually everywhere, but not every move is valid or every move is safe. So in order for that to check, we want to see, okay, if the king is in this position, is there any opponent piece that can attack our king? First of all, let's create a new variable right here. Let safe is equal to true. And then if the move is safe, we want to keep it. If the move is not safe, if not safe, then we want to remove the move from possible moves. Okay, so right now every move is safe. If it is not safe, it should be removed from the possible moves. And here we want to apply some logic. Determine if the move is safe. How do we know if the move is safe? Well, let's start with the easy determination. And that is, if an opponent piece can move into that position, the move is not safe. All right, so let's see. What we can do for that is we can loop through all the pieces. So we say for const this.pieces, and then we only want to loop through our own pieces, because right now we are looking from the opponent's view and we want to know if the white pieces can attack the king. So we want to say if p.team is equal to team type.opponent. If it is his own team, we don't want to do anything, so we skip it. Continue. Okay, then we want to check if it is our team, so that's where we are at right now. If any of the possible moves is equal to the king position, then it is not safe. So what we can say is if p.possibleMoves.sum, and then we have p.same position. If it is the same position as the move of the king right now, so we say same position of move, then we want to say safe is equal to false. All right, so now we know if any of the moves that the king makes is false, determining by if we can make that move. And now this will work for 99% of the cases, but not all cases. And that is when we have a pawn, because a pawn can move forward, but it can attack diagonally. So for the pawn, we don't want to do this. If p dot is pawn, continue. So right now we are just leaving the pawn out of it, pawns cannot attack king, it's all fine. We first want to implement this. So if it is not safe, we want to remove the move from the possible moves. So we say king.possibleMoves is possible moves dot filter, and then we want to filter out the move that we don't want. We say m.same position as the current move, and then we don't want this position, so we want all the possible moves that don't have the same position as the current move. We can add this above here, like so. And now let's refresh the page. If we move the king right here, well, we still can move onto the pawn attack areas, but say we move one down. Oh, we cannot move one down. As you can see, there is no circle right here because the horse is attacking. Great. We also see that the queen has, well, a straight line right here, so the king can also not move there. So there are no dots either. Okay, let's test it out a little bit more. Let's move the rook right there. Right now we see 2 dots on the green tiles right there. If we move the rook to here, we don't see the green dots because the rook is preventing the king from moving there. Great, so for the normal pieces, this is working. Let's also check the horse for really quick. So now the king shouldn't be able to stand in his own position. So let's move to here, and we see that we cannot move down because the horse is attacking this tile. Great. All right, so we now have the logic for all the pieces except for the pawn. So for the pawn, we are going to do something special. All right, so for the pawn right here, we were continuing. Not anymore. If the piece is a pawn, we want to get all the possible moves for that pawn. So we say const possible pawn moves is equal to get, let's see, what was the function called? This.get valid moves. And we want to get the valid moves for the current pawn. So that will be p, and then this.pieces. And in this .pieces array, we have updated the position of the king. So it is now determining the valid moves from the pawn based on, well, the updated position with the king. And then, well, it's actually the same. We just want to check if there is any move from the pawn that is aligned with the move from the king. And if there is, then we want to set save to false. All right, so instead of assigning the get valid moves to a piece, we just save those moves inside a variable right here, and then we check it. We don't do anything else with it. Let's save this up, then move this pawn up right here. If we move the king to here, we see that we cannot move down, but we can also not move to the left. That is not exactly how it should work, because the pawn cannot attack upwards. There is a quick and easy fix for this, which is if the p.move and then the x value is the same, then we know that the pawn is moving straight forward, right? So if the x value, which means this value, I'm moving from left to right. Oh, that was not what I was trying to do. So if the x value of the pawn, the horizontal value, is the same, then we are moving vertical. Might be a little bit confusing, but you'll get what I mean, I hope. So if the x value is the same, we don't want to check it. So right here, if p.x is equal to, and then we want, oh, but we have double p, because here we have the piece, and here we have the possible pawn moves. So let's rename this to ppm, possible pawn moves, or possible pawn move, like so. If ppm.x is equal to p.position.x, and then we have this, then we want to set save to false. Except we want this to be not true. So if the x position is not the same, and it is attacking the king, then it's not safe. Let's refresh it. Same situation. We can still not move there. All right, I see what's going on. We are now executing this function, or this if statement, and this if statement as well. We want to execute only this one if this one is not true. So if the move is a, or as a piece is a pawn, we want to do this. If it is not a pawn, we want to do this. Yeah, a simple else if will fix this. So now let's move up, move down, and then move to here. And we see that we can move to the correct positions, which is great. We can take the pawn, but we cannot move to the left and right. And say if we move the queen to here, can we still take the pawn? Well, yes, we can. However, we shouldn't be able to do that since the queen can then attack the king. The king can still take the pawn because the queen thinks there is a white pawn, so she cannot move there. So if the king moves here, well, the queen thinks that she cannot hit him because there is a white pawn protecting him. In order to fix that, we want to check if there is any piece at the location that the king is going to move to. So let's say if, and then we say this.pieces dot find, and then p dot same position as the move. If there is a piece with that position, so let's say const piece at destination is equal to that, like so. If there is a piece at destination, we want to remove it. If there is a piece at the destination, remove it, because otherwise the queen will think that the king has protection or is protected by the white pawn, which he is not. So then we want to update the piece array by removing this piece. So we want to say this.pieces.filter, and then we want to say we want the pieces to be equal. So we say this.pieces is equal to this.piece.filter p dot same position move, and we only want to have the pieces which don't have the same position as the destination move. And now that I have written this, I think that, yeah, well, there it goes already. We want to do the king movement after this, because otherwise the code right here will say, hey, there is a king at the destination move. Let's remove it. Well, we don't want that, so we want to update the king position after it. So now we shouldn't see the king disappearing. Great. And right now, if we move to here, the pawn disappears. And it is also entirely correct because we are removing the pawn and we are never getting it back. So a simulation is a simulation because it didn't happen in reality. It is only pretending, or it's only simulation. However, right now we are definitely editing the real life or the actual pieces array. So we don't want that. What we do want to do is we want to say const cloned board or simulated board is equal to this.clone. So now we have a clone of this board. Then what we want to do is we want all the this references to use the simulated board. So also right here, the pieces, simulated board get valid move, simulated board that pieces. Do we still have this somewhere? Let's do a search. At the bottom, but not at the top, I think. So calculate moves. This is all still correct. Here is a simulation. And here it ends. Now, I think we're clear. Okay, so let's try this again. And now we create a new board every time we create a simulated move. And as you can see, we can move to this position again. So we might have broken something. I think that I know what has been going wrong. And that is that the king position isn't being applied to the simulated board. So now we can execute this at first or at the beginning once again, because we are updating the king position in the actual board. Then we simulate, or then we clone the board into a simulated board, and then we remove pieces from that board, so we won't remove our king. Well, let's test it out. The king is still existing, and it can still move downwards. Alright, I did some debugging, and it seems like if we do this right here, it does get picked up by the simulated board, but then the simulated board removes the king, which was exactly the same scenario as that we had before. So in order for this to be fixed, we want to update the simulated board king position after we have done the check right here. So before it was right here. Now what we want to do is we want to find the king of the simulated board. So let's say simulated board dot find pieces dot find p dot is king and p dot team is equal to team type dot opponent. And then we want to say dot position is equal to move. So right here we see that the position may be null and we cannot do an assignment to it if it is null. So in order for that to get fixed, we can assign this to a variable named const simulated king is equal to this right here, like so. And then right here we want to say simulated king position is equal to move. And we can then replace the question mark with an exclamation mark in order to tell the compiler that we know for sure that the king cannot be undefined. What we could also do is this that we had right here. Well, we can also do that. And then we say if the simulated king is undefined, then we want to continue. Otherwise, we want to assign the position of the simulated king to the move. Now let's refresh this and then let's go to here and then down to here. And we see that we cannot move to any of the squares down here. Great. Let's try it again with the example that we had created before. If we move down to here, we see that we cannot move to the left, but we can still take the pawn. And if we move the queen to here, we see that we can also still take the pawn. And the reason why we can still hit the pawn is because, well, right here, we remove the pawn from the board. Right here, we update the king to the correct board position. So in short, this creates a new board state, but the queen, her moves are still calculated based on the old board state. So after we have done all those transitions, we want to update the positions for the queen. And to be fair, it's not only the queen. We should update the moves for the bishop, the knight, and the rook as well. But let's start with the queen. We want to say for const queen in pieces dot filter, because we only want to calculate our queens, not the opponent queens. Is queen and p dot and p dot team is equal to team type dot our. So now we only have our queens. We can type of queen dot possibleMoves is equal to simulate the board dot calculate all moves for get valid moves for the queen, and then the simulated board dot pieces. And then right here, we don't want to say this dot pieces, but also simulated board dot pieces. Right, so now our example should work. Now we can take it. Now we cannot take it anymore. Great. This is really great because as you can see, it's working. We cannot take the pawn because the queen will attack us. It will slap us back. All right, that was the queen. We can really easily extend this to enemy pieces by saying no queen anymore, only the enemy pieces. And then we say enemy, the possible moves is this. Because if we, can we still move? Yes. If we right now move the king to here, is that correct? Yes. And say we want to take this, we can. But what if the bishop is right here? We shouldn't be able to take it because the bishop will hit us. Well, if we save this up and refresh the page, our dreams come true, because right now, if we move the bishop to here, we cannot take it. Great, because now the game knows, hey, if you take this, the bishop will hit you. This is looking really promising. Cool. Now we have it working, but we are going to refactor this a little bit. So instead of putting it all in a calculate all moves function, we're going to create a new function right here, which is going to be named calculate check king moves. And here we want to check if the king moves are legit. So right here, we can cut this all away and then put this in a check king moves. So now this is in its own function. Well, it's a little bit more neat, a little bit more clean. Let's see, here we take the king. If the king is undefined, we want to return. And then we take the original king position. Is that still needed? Because we never modify the king, right? We only modify the simulated king. I think that's correct. So we can remove this line, this line. Well, that's already 3 lines of code less. Let's see if our function is still working. We cannot move to there. Can we take it? No. Great, still working. And then the next thing that we want to do is, well, something a little bit different. It's this. Well, right here, we fetch the king, which is totally fine. And here we say if it doesn't have possible moves, then we want to return, which is also fine. This is actually pretty good because I wanted to say we always know that the possible moves will be defined, but they might be undefined. Yeah, this is okay. Here we have destination. This should be destination. So let's press Ctrl D. Destination. Yeah, press Ctrl D to select the next occurrence, which we just did. We loop through all the possible king moves, and then we clone the board for each king move so we can simulate it. Then we get the piece at the destination, and if there is a piece right there, we want to remove it. Then we want to put the king in that position. Right? Is it correct? Yes. Then what we want to do, if is the simulated king undefined, then we want to return it. Is it correct? No. Here we get the simulated king, and if the simulated king is undefined, we want to continue. Otherwise, we want to move. Okay, so in this case, we always know that the king should be available, right? Because if the king is available right here, then it should be available in the simulated board. Are you with me? Okay, so let's see what we have of references. Yeah, what we could do, I'm not saying this is good practice, but what we could do is we could remove this. And then right here, we add an exclamation mark. And this is telling the compiler like, hey, the simulated king is always there. We tell the compiler that the simulated king is always present. And the reason I'm doing this is because, well, normally it's not good because we might crash right here because we have a null reference or an undefined reference. But up here, we already check for the king. And here we clone the board. So, well, if we already have the king on the board, we should have it on the simulated board, right? Then here we have other enemy pieces. We check if the enemy piece is our team. And then let's see, we want to get the valid moves. Enemy.possibleMoves is equal to that. And then we loop through the pieces. Okay, so here we update the enemy moves. That's fine, that's fine. Then here we loop through it, and if it's not safe, then we want to do something. Yeah, so this might be something that we could do more efficient because we don't need a save keyword, I think. It might be more readable. Let's see. If it is opponent, continue, that's fine. If it is a pawn, then we want to set this to false. What we could also say is, yeah, we could write this line of code right here and right here, and then break out of this for loop. Well, we could also break out of this for loop immediately. So once we have one piece that can attack our king, we break out of the for loop. Because we don't need to check all the remaining pieces. Once we know that one piece can hit our king, it's enough, it's over. We want to break out of this for loop right here. So that's fine. Let's see, possible moves, yes, that's correct. And that's also good. Remove the move from possible moves. And that's also pretty good. And then we have our king check moves. Let's check if it is still working. We can only move down, and then we can only move, yeah. And if we move this one, we cannot move, correct. Great. All right, so to wrap it up, we are going to add one more thing, and that will be actually preventing the king. Because if we move the king to here, we can still move the king downwards. Even though this spot is very dangerous for the king, we can still move it there. So we're going to add a simple fix for this. And that is right here. Right here, we have the playMove function. And in this function, we check if the move is valid. And the way that we check if it is valid is, well, we do all the logic that we did up here. Again, I think. So pawn move, what does this do? It's from the pawn rules. If we go to our board, calculate all moves, this get valid moves, get possible pawn moves. This right here, is this the same as that we have up here? Export const pawn move. I think it is the same, but we don't know for sure. There might be a little bit of difference. However, what we are going to do is something completely different. Instead of recalculating if it is a valid move right here, we want to not recalculate it. We want to do this. Valid move is equal to piece.possibleMoves. Oh, play piece. The possible moves dot sum m dot same position as the destination. All right. So in order for this to work, the played piece should have possible moves. So let's say if played piece dot possible moves is equal to undefined, let's just return. We don't want to do anything, and we need to return a boolean, so we return false. The move may not be executed. Yeah, this is something that we return. Let's create this variable behind here. So once we play a move, the first thing we do is we check if the piece has possible moves. If it doesn't have any, we return false, so we cannot play the move. And then right here, this line is changed. Right now, this line checks if the possible moves from the king contains the destination. Well, not only the king, other moves. So this means that if you can see the dots, it means you can move there. And you cannot move to any other position. And this also fixes, I thought at least, the problem that we have right here. Because, well, the move is not valid. Okay, but if we move back to our scenario with the king, let's move a pawn to here. We cannot move onto the pawn. And as you can see, it snaps right back. Great. What if you move a pawn to here? We cannot move there either. So it seems like this is working wonderful. Well, we still need to do something for the king and check, but it's for another time. One final thing, in order to fix the problem that a viewer has found out, which was if the pawn goes to the other side immediately, we get this. That's not what we want. So we want to say if the move is not valid, just return. So we say if not valid move, return false. So now if we take a pawn and move to the other side of the board, it will get snapped back right at this position. Only way for the pawn to move there is to move like any other piece would, just with normal moves. Great. I want to thank you for watching. I hope you could follow along. Leave a like down below, comment, subscribe, and I'll see you in the next episode. Bye.